with another example on integration by parts method, and in this example we're doing definite integrals. Okay, so far for the last 5 examples all we did was indefinite integrals. So this also works like how you would evaluate the integral for an indefinite integral, but then one has to use the what you call the fundamental theorem of calculus to finally evaluate the integral with the lower limit and the upper limit. So guys, first of all, we are going to looking at this integral here. We're going to first see what we have to use as an f and what we can use as a g. So again, we can see that the algebraic function comes before the trig functions, right? Because here there's a product of an algebraic function x squared and the trig function cosine function, right? So we have to compare the algebraic and the trig function. Again, so it's in the right order. That means we have to treat this as an f and this as an g. Once we do that, then let us get started and start writing the using this right hand side formula. The formula is already, the integration by parts formula is already right up here. So let us start doing it, and then keep in mind we have to use the fundamental theorem of calculus to actually finally evaluate, because we have a lower limit and the upper limit. So guys, just follow through the steps carefully. The first thing is just write the x squared, then integral of the cosine of pi x dx. Okay, that's the first half of this formula, and then minus integral of f prime, the derivative of x squared, which we all know is 2 times x, then times integral of what do I have? Again, the same thing, cosine pi x dx, and then there is another dx all the way at the end. Okay, step number 1. Then let us move on. Guys, here's the thing. Let us first evaluate the integral. So there's 2 halves. So let us first, once we evaluate and whole complete integral, then then only we should apply the limits, which is the lower limit and the upper limit, or then we should use the fundamental theorem of calculus. So in this case, let us start evaluating this, and then we can use the fundamental theorem of calculus on this piece. With this, we may have to do some extra steps before we can actually apply the fundamental theorem of calculus. But sometimes people like to apply it all the way at the end for this whole, all the terms. That is fine, but I like to break it into 2 pieces, because this is like half and this is the other half. So I apply the fundamental theorem of calculus with the first piece and then with the second piece. Okay, here I have x squared, and then the cosine, the integral of cosine is sine, right? So it is going to be sine pi x, but we still have to do one more thing. You have to divide by the derivative of the inner, which in this case is pi, or you can also think of that as the coefficient of x. So you divide by pi. We know with the derivatives of cosine of pi x, you would multiply by pi. That's the chain rule. But for these integrals of the form, if this piece is of the form ax plus b, and in this case this is a linear form, then you take the integral, and then you just take the integral of the cosine, and then you divide by that coefficient of x, and I like to think of that as the derivative of that inner. So that's it. So this is already simplified in the sense that we already evaluated the integral for this half. So once we evaluated the integral, so integral is all gone, like it's taken care of, then I'm going to start applying the limit. Okay, so upper limit is 1 and lower limit is 0, which means the x value is 1 here, and then x value is also 0. It's between 0 and 1. Then minus, guys, this 2 we can already take it outside, and then let us see what is left inside. So we have an x, and then we can simplify this integral of cosine, same thing, sine of pi x divided by the pi. Okay, that takes care of that piece, but we were not able to we have not yet evaluated this integral yet, so we are not going to apply the fundamental theorem of calculus yet. But for this guy, we can already start doing it. So first you have to substitute for x to 1, right? You have to substitute 1 for x, so it will look like this: 1 squared sine of pi times 1, which is just sine pi, over pi, and then minus, that is from the fundamental theorem of calculus, f of b minus f of a. So this is going to be 0 squared, right? For x is, when x is 0, sine of pi times 0, which is 0, over pi. Okay, we got to write that step, and then let us see what's going on this side, this part. So you got to take, I can take that pi outside because it's a constant, so that's what we do with the constants, we take them outside. And inside here I have x times sine of pi x. So guys, it seems like we were not able to kind of simplify, or we will not be able to simplify it right here. So we may have to again use the integration by parts method. But the good news is that we started with an quadratic of the power x squared, but by using or by applying the method of this integration by parts method, we were able to get it down to x to the power 1. So if we apply the integration by parts method one more time, we would be even able to get rid of that x, and that would help us to finally simplify. Okay, so again, we need more space for that, so we're going to start getting rid of some of the stuff here, and then try to squeeze in the rest of the steps. So from here, I'll get rid of this, and then let us see how far we can get from with this. So guys, from here, well, sine of pi is 0. That makes this term 0. 0 times whatever is 0. So this whole term basically becomes 0, which is good. It just makes our life a little easier. So it's 0 minus 2 over pi, right? 2 over pi. And this, again, you got to treat one of these as f and one of these as the g function. Obvious, the choice is obvious. Algebraic as f and the trig function as the g function. We know that based on this. And now let us again use the integration by parts formula. I'm going to put it in like a square bracket. So first f, which is just x, then integral of what do I have? I have the integral of the sine pi x dx. And then guys, I have a minus here of the formula, and then integral of the, first I have to do the derivative of x. Derivative of x is just simply 1, which is good. So 1 times, so it's 1 times, then again integral of sine pi x dx, and then there's another dx, okay? Of course this, now I don't have enough space to even I can close the square bracket because we started one, so we got to close one. Let us take it from here, guys. This 0 does not matter. Let us just write 2 over pi, and let's see what we can do with the quantities inside the parentheses. So first I have x, then we can evaluate that integral of sine. We know integral of sine is negative cosine, so I can already put a negative outside here in front of x. So it's negative cosine pi x, but you got to divide by pi again. Okay, that is the integral of that, but now it is like simplified. We have evaluated the integral. It is safe to actually put the limits now, 1 and 0. I'm just writing them. I did not evaluate. I will evaluate in the next step. Then let us see, minus integral, guys, this 1 does not do anything here, so 1 times the integral of that. But integral of this, guys, again, negative cosine pi x over pi, and then there's a dx. Okay. Well, the good thing is that we don't have any other quantity here with the cosine, so we should be able, in the next step, we should be able to actually evaluate this integral using the simple rules, okay, or the basic rules. Okay, guys, let us go ahead and see what else we have to do. Well, here I started this square bracket, I got to close it. Want to make sure that I did not make any mistakes, careless mistakes. I'm just checking my work, and I hope that when you guys do these things, you got to check your work as well at each and every step. And then let us move on. Guys, negative 2 over pi, I'm going to leave it outside. And now I'm going to substitute this 1 for x first and then 0. So 1 means, well, negative will stay, negative 1 cosine of pi. X is 1 divided by pi minus, guys, for the next, I have to apply x0. So it is minus, let me put it in parentheses because these are like two terms now. So this, we're just evaluating this piece. So this is f of b, and now minus f of a, which is minus 0 times cosine of pi times 0, which is cosine of 0 over pi, and I'm closing this regular parentheses, and then there's a minus this guy right here. Guys, again, negative times negative is positive, so it will change to a positive, right? This is just for this piece, using the fundamental theorem of calculus on this. f of b minus f of a. That's how we use the fundamental theorem of calculus. Once we evaluate the integral, we evaluate it at the upper limit, and we evaluate at the lower limit, and we subtract them. Okay. Then here, negative times negative is positive. Guys, there's a pi downstairs, so I can already take that outside as 1 over pi. That's the constant, right? Pi is a constant. So it would be then integral of cosine of pi x dx. Okay, so I think I need even more space to evaluate this integral. Let us see if we can squeeze everything in finally in this space. I think so, but let's try. Okay, so far so good. Let us move on. Guys, this term right here is a 0 times whatever, so it just does not matter, it becomes 0. But here, guys, cosine of pi is -1. So you can use your calculator for that. If we don't remember, then we got to use our calculator, but keep in mind that the mode should be in radians. Or if you have a unit circle handy with you, you can use your unit circle as well. So cosine of pi is -1. So -1 times -1 becomes +1, so it finally becomes 1 over pi. Because this term is 0, this becomes 1 over pi. So these two terms are taken care of. Now let us move on to this next one. Guys, here I have plus 1 over pi, and then the integral of this cosine. Integral of cosine is what? Is sine. So integral of cosine is sine of pi x, but you got to divide by pi as well. We know that. And then we applied the fundamental theorem of calculus on the first piece, but we also have to apply it to the second piece as well, because now we have evaluated the integral. There's no more integrals here. Guys, keep in mind, we apply the fundamental theorem of calculus once the integrals are already done, once we evaluate the integrals, okay? So what is the limits? 1 and 0. And that 1 and 0 is only for this. This has already been taken care of. And if you like to put it in parentheses so that we don't confuse, you can do that. And you can put this one in parentheses, and this is only for the second half. Let us simplify. There's probably 1 or 2 more steps. So it is -2 over pi. Let me try to take it up here. So guys, this is -2 over pi, -2 over pi, which is this term. And then let us see what is left inside. So I have 1 over pi here, and then plus I have, guys, pi times pi is pi square. So it is, and let us apply that, let us apply the upper limit and the lower limit. So it will be sine of pi, because x is 1, over pi square. I'll put it in the parentheses. Okay, there's a parentheses here. Minus is from the fundamental theorem of calculus, f of b minus f of a. Guys, x equal to 0. So sine of pi times 0 is just 0. And downstairs I still have pi square. Of course, I have to close this. Okay, we're almost there. So here from here we have -2 over pi, and then I have 1 over pi. We can simplify this guy, guys. The good news is that sine pi is 0 and sine 0 is 0. So what does that mean? That means 0 divided by pi square, which is also going to be 0, and 0 divided by pi square again, that's going to be 0. So this whole term, these two terms are equal to 0. So it is just basically plus 0. So what are we left with? -2 over pi, just times 1 over pi. And when I multiply these two, I get -2 over pi square. That is the final. Let me make sure that this looks like a pi square and not pi times 2. So this is pi square. This is the final answer, the final integral for x squared cosine of pi x. But from the limits of integral are from 0 to 1. So guys, this problem is not like too complicated on its own. Of course, there is like, you have to use the integration by parts twice. But the tricky piece, or the most important piece here, is to like use or apply the fundamental theorem of calculus carefully. Again, if you are like watching this video where we are dealing with this type of example, I'm hoping and expecting that you have already watched my videos on fundamental theorem of calculus and applying that theorem to different types of integrals and evaluating those integrals. So if you have already seen those, then it should not be such a big problem. like trying to do this one, but again there's a lot of steps and you have to be very careful when you apply these limits, the lower limit and the upper limit. Guys, practice this particular problem on your own. Check these steps, practice it on your own. Once you get the right answer, then try practicing other problems which have limits of integration and where one has to use the integration by parts. Okay, so guys, keep working on these problems. I will see you next time with another problem. Till then, guys, take care.